In this video, we will discuss the Lotic component of the Bureau of Land Management's Assessment, Inventory, and Monitoring, or AIM strategy. The term Lotic refers to streams and rivers. For the BLM to successfully manage public land in accordance with their mission and other policy, it is essential to assess the condition and trend of the resources it manages. For much of the BLM's history, different techniques, tools, methods, and data sources were used among field offices for monitoring and assessment and were not standardized across the agency. In a government directive to increase the effectiveness and standardization of data, the BLM created the Assessment, Inventory, and Monitoring, or AIM strategy. 3 resources are currently addressed: terrestrial, lentic, and Lotic systems. The AIM strategy relies on 5 key principles: structured implementation to guide monitoring program development, implementation, and management decisions; standardized field methods to allow data comparisons throughout the BLM and in collaboration with BLM partners; appropriate sample designs to minimize bias and maximize what can be learned from collected data; integration with remote sensing to optimize sampling and calibrate continuous map products; data management and stewardship to ensure data quality, accessibility, and use. For the rest of this video, we will go through applications of each of the 5 principles to Lotic AIM. Structured implementation consists of all aspects of AIM implementation, from the identification of management and monitoring objectives, to study designs, data collection and management, to using the data to inform management decisions. These and all other AIM steps are supported by a network of subject matter experts, including state leads, monitoring coordinators, agency partners, and the NOC AIM team. Lotic AIM indicators were selected to be applicable across a wide range of ecosystems and to measure the fundamental components of functioning stream and river systems. The field methods assess components of water quality, watershed function and in-stream habitat quality, and biodiversity and riparian habitat quality. Additionally, field methods were selected to maximize compatibility with existing monitoring programs managed by the BLM and other agencies. This table details the protocol's compatibility to other Lotic sampling protocols, such as MIM, AREMP, PIBO, and EPA. More information on indicator selection can be found in Technical Reference 1735-1. The Lotic AIM indicators consist of 11 core indicators that are representative of a consistent, quantitative approach for assessing the attainment of State Clean Water Act standards and other BLM policies for streams and rivers. There are 6 covariates to assist in interpreting the core indicator data. 8 contingent methods are suggested, but should only be collected in areas where they relate to management questions. The collection of supplemental methods is highly encouraged for specific and localized management questions. Examples might include surveys for special status species, such as spring snails, or the collection of water samples to quantify fecal coliform concentrations. Technical Reference 1735-2, the National AIM Aquatic Monitoring Framework Field Protocol for Weightable Lotic Systems, is a detailed protocol to collect all data associated with Lotic AIM core, covariate, and contingent methods. If you are collecting data, make sure you have this protocol with you at all times during field sampling. Sample designs refer to the process of selecting stream or river reaches to be sampled, as well as how frequently data will be collected. AIM is actively used to address a variety of management objectives, from small-scale stream restoration or reclamation to national-level reporting. Thus, a variety of appropriate sample designs are utilized. The 2 main design types field crews will encounter are probabilistic and targeted. Probabilistic designs are sometimes referred to as spatially balanced random sample designs. Targeted designs are used to address management questions for individual streams or rivers or sections of streams, whereas random sample designs are used to address the condition and trend of streams and rivers at broad spatial scales, such as field office, districts, state, or national level reporting. The sample design also determines if and how often sample reaches will be resampled. Crews will visit both revisit reaches and never revisit reaches. Revisit reaches are sampled repeatedly to assess change through time, i.e. trend, and never revisit reaches are sampled only once. These concepts are important in terms of field crews knowing whether a sample reach needs to be monumented or whether monuments exist for relocating sample reaches. Reach monuments are physical markers that help crews relocate sample reaches and are discussed in later videos and the field protocol. For more information on appropriate design selection and use, see the AIM website and the Lotic Evaluation and Design Management Protocol. The integration of remote sensing technologies with Lotic AIM is currently being developed to help understand concepts such as flow permanence in streams and to better interpret a specific reach's potential for interpreting collected data. AIM data management and stewardship is based on making data accessible, understandable, and usable for management decisions. One critical step in this process is the collection of data electronically and the storage of data in a centralized database. Field crews collect data on iPads using SARA, the Stream and River Assessment Hub app, and data are subsequently ingested into Aquatic, the public and BLM Lotic AIM database. AIM data can be found at this web address. Electronic data capture allows real-time QA/QC checks to be implemented in the field, prevents transcription errors, and allows easy standardized permanent storage of AIM data, including photos and GPS coordinates. Additionally, standard QA/QC and data management practices are detailed in the Lotic Data Management and SARA protocol. Structured implementation is the backbone of the AIM strategy, and each of the core principles addresses pieces of this. The AIM strategy has led to high-quality, consistent data across the BLM, and data have been used to address a range of applications, including grazing permit renewals, treatment effectiveness, and baseline condition assessments. For more information and to consult documents and protocols, visit the AIM website. For additional assistance, you can contact the National AIM team. The National AIM team provides assistance to individuals implementing terrestrial, lentic, and Lotic AIM, or using AIM data. This is the end of the AIM introduction tutorial. Please contact the National AIM team for additional AIM questions.